All right, so we have a wonderful panel of maintenance and operators, and I'd like to start off with John back there. John, would you introduce yourself a little bit and tell the audience?
How do you do? I'm John McNeil. I was 17 years with the SR-71 program. I was primarily electronic warfare specialist, but I also worked in the other avionics compartments. It was a great program to be with, and it was important that we were doing a mission every time we flew.
My name is Don Bullock. I was with the SR-71 program 1973 to 1977, 4 years. I flew 480 hours, about 125 missions. 29 of those missions were actual collection missions, and super programs, super people, and the sound of freedom was heard around the world.
Hi, I'm B.C. Thomas. I was a pilot in the SR-71, and my background was that I was a tanker pilot, a C-130 pilot, a B-57 pilot, RB-57F, and I went to test pilot school, and then I went to the SR-71 and stayed there for 11 years.
My name is Steve Justice. I'm the odd person out here. I'm an engineer from the Lockheed Skunk Works. I was the historian for the group. Blackbird has been a passion of mine since it first showed up in the public, and I have loved airplanes since I was his age.
Good morning. I'm Rob Butterfield. I entered the program in '82 to '89. I was a crew chief for 2 years, and then they fired me and moved me into supervision in RAF Mildenhall, England, where I stayed for 5 years, and that was probably the best assignment I had in my whole career. People work together like a Swiss clock. This program is unbelievable, and it also inspired me and kept me going as well.
My name is Stormy Boudreau. I was a pilot. I was B.C. Thomas's student. B.C. was my instructor. And I flew for about 4 years and didn't amass a lot of hours compared to some of the other people that we'll be able to talk to, some 500 hours in the airplane or so. But I'm going to give you an overall presentation of what the SR is, and then we're going to open up to questions and answers. And that's where the fun begins, because you start asking a question and then a story comes out from these people here that may not be written down anywhere until you hear it here. So the genius behind this aircraft is Kelly Johnson. His background in building so many airplanes, the two that you see here are his creations as well as a number of others. It's just unbelievable how productive this man was during his career. Those of us who were anywhere associated with him, flew airplanes that he built, are simply in awe of this gentleman. The SR-71's characteristics, they say it's the last airplane designed with the slide rule. Well, technically, if you go back into the 50s when the SR-71 was designed, they did have a couple of computers. They would fit into a room that was about half the size of this, and if you gave them a question, you might get the answer back the next day or so, and then you'd have to put in a bunch of punch cards to find out what the next thing it was. It was far easier to use the slide rule than it was to have the machine at that time calculate things for you. You have more processing power in your pocket right now than that machine had. It was the aircraft, the first of the stealthy aircraft from America. I'll point out some of the design features of its shape, as well as some of the construction material that helped it to become stealthy. The third bullet down about heat, that was the biggest thing with the SR-71, is the whole airplane got so hot, you would probably think, oh, if only they could use modern technology in the SR-71. Well, as soon as you put any of these little processors that we so depend upon that fill up our pockets with phones and our hands with an iPad and stuff, and then you subject them to 500 degrees or 800 degrees, they don't do very well. And then if you cooled it off to minus 60 or 70 degrees, they don't do so well. So a lot of what went into the airplane had to do with the excessive heat that the airplane had to deal with. Then in order to deal with that, titanium was used, and you can see up there it says 93% of it was titanium. And the other parts of it we don't really like to brag about right now, because at the time we didn't understand what the ramifications were of it, but the composite material that made up some of the skins and other areas of it was made up of a silicone asbestos material. And now we know that that's a pretty caustic, toxic type material to have and drill holes in and do stuff, but that's what we were using at the time. It does have very good heat acceptance properties, but not very good human acceptance properties. The special fuel that had to be developed for it, JP7, it was non-volatile. In other words, it didn't put off a vapor. You know, you're always warned about having a gasoline in your garage where you may have a hot water heater or something to where it would, the vapor would catch fire and explode on you. And they were very concerned about the fuel as it went up to altitude, vaporizing and causing some issues. And so they developed a fuel that is very low in that, but it then required an extremely high temperature to ignite it. So jet engines use a spark plug like sort of like a super duper spark plug in your car. And that wouldn't ignite this kind of fuel. So they had to come up with something that was a chemical that when exposed to the air or the atmosphere would burst into flames, and that's what we used as the igniter to light the engines off on the ground, and every time we lit the afterburner, that's what kicked off the afterburner. Just trying to flip the little round knob on the Zippo wasn't going to work. We had a fleet of tankers at Beale, KC-135Q models. They had separate tanks, or they had the same tanks that all the others, but they were segregated so as to keep the fuel. Some people will say that tankers couldn't use the fuel. That's not true. They would not use them for takeoff or landing because they wanted to use the fuel that the airplane was certified for, which at that time was JP4, but the JP7 was stored, and they could burn it at cruise, where if something happened, they had enough time to put, it's sort of like using extra high octane fuel in your car that's designed for low octane fuel. It works, but it may not be the best thing for it. In order to keep the fuel, which ignition point was around 350 degrees, from igniting inside the tanks, because the temperature inside the tank would exceed 350 degrees. And I think I see a couple of Boy Scouts here. Most Boy Scouts know that if you have fuel, air, and an ignition source, you can have a fire. Well, if you had air inside the tank, you had fuel inside the tank, and it's hot enough to combust, then you could have fire right inside the tank. So they used liquid nitrogen pumped from the container that had it to each of the tanks, and as the fuel started to burn down, instead of like your automobile where it vents to the atmosphere and allow air to come into it, we bubbled up liquid nitrogen, changing it into gaseous nitrogen, and that's what filled the space above the fuel called the ullage, and it filled it with nitrogen and kept it inert so that you cut out one of those three legs that give you fire so that the airplane, and so when you ran out of liquid nitrogen, we were now restricted to 2.4 Mach only. When I say that to pilots, I say, we're restricted to only 2.4 Mach. Only, they say, because the rest of them, what's really different about the SR-71 compared to other fighters, yep, we have an F-15, it can go Mach 2.2. The F-4 that I've learned to fly airplanes in after my basic pilot training, I've been 2.2 in it. All the other fighters that I know of, if you're going to go at Mach 2, 1.8, something like that, you go, well, that airplane goes fast. Yeah. You take the tanks off of it so that it's clean. You take everything else off of it. You find the coldest spot in the atmosphere to accelerate. You may even have to unload it a couple of times to get it going. And you reach that speed and you go, wow, look at me. Now, the next thing I'm doing, I'm looking for a place to land because I just ran it out of gas to get it going that fast. Okay? If you hang tanks on it, you can't go that fast. You hang missiles on it, you can't go that fast. So when you, but the SR-71 would go to Mach 3 and cruise there for an hour. And if you said, I have to go further than what that range would be, well, this is one of the only, I think it's the only airplane I know of, that when you went a little faster, its fuel flow got better. So as you went faster and faster, it used less fuel to be there. And so you could go a long time. So an hour and a half at Mach 3 just rolls the socks down on fighter pilots who are used to that being a point that you might say that airplane can go to rather than a place where the airplane cruises at routinely in every time it flies. Oh, special hydraulic fluids. At the time, there were two types of hydraulic fluids in the 1950s. One that was designed to be at about 150-degree temperature, and then there was a super special one that would take you up to about 225 to 250 degrees. Well, you'll see later on that this airplane's average temperature was somewhere between 500 and 600 degrees, and where the hydraulic lines were running for the overall, they were somewhere between 500 and 600 degrees. If you have a fluid that's not going to work very well above 225 or 250 degrees, then you have to invent something new that'll work there. The fuel was used as coolant and hydraulics for the engine nozzles, and this is what I think is interesting. Many people think of the SR-71 as the Blackbird, whereas the airplane had a family. There were 4 different airplanes that are referred to as Blackbird aircraft. So many people just talk about the SR-71, but there was the original A-12, which was a single-seat airplane. If you looked at it, unless you're a very knowledgeable person, you go, well, that's an SR-71. Well, no, if you look closely, there's not a rear seat. And if you were to look at it very, very closely, you'd see it's about 3 or 4 feet shorter, and it has one less fuel tank. So that makes an advantage in that it's a little bit lighter, so it could go ever so slightly higher. And some say that it could go a little faster. But then you had the SR-71, which is a derivative, added that fuel tank that's missing, a little bit longer, not much, added a second person, because when I learned how to fly this airplane and saw how busy I was just keeping the pointy end going straight, not having to worry about when to turn the cameras on or when to turn something else on, or if somebody started to try to interfere with my airplane, how to turn a jammer on or where to go and to do navigation. The person in the single-seat A-12 was the proverbial one-armed paper hanger. Really very, very busy. If everything worked fine, it must have went very well. And then they developed a YF-12, which was an interceptor version. So the F part of it's for fighter, and they peeled back the leading edge of the chine so that the radar that they put in it, and then the missiles that they would embed inside of it. So a couple of years ago, people were concerned about building some new fighter-type airplanes that had weapon bays that they were going to eject out, and they were concerned about ejecting out a missile at greater than Mach 1 and maybe close to Mach 2. And some of us who had been around this airplane said, well, we've already proven that you can do that at Mach 3. What's your problem? We can explain that to you. And then there was the version of the airplane called an M21 that we don't have a copy of here. The only living existence, or the only existing one right now, is up in Seattle at the Flight Museum up there. But it carried the D-21, a Mach 3 plus drone on the back of it. And a picture of it you can see mounted on the mothership down there at the bottom. So the airplane was 107 foot long. You can read all of these things. It was just marvelous. And even today, when you look at it, it looks like science fiction or something from that you would put together today that would be for the future from today. It's really a purely sinister-looking aircraft. Here's the temperatures that I was talking about, and some of the things, the pilot's window, they're triple-paned glass, not just ordinary glass, special glass. If I take my hand while I'm flying and pull it up, put the back of my hand against the window for about 1 or 2 seconds, I can't stand it any longer, and I take my hand down, and now I'm trying to bend my wrist to keep the glove from touching the back of my hand to try and cool it off. It would heat up very quickly. However, the little cocoon right around you was kept at a pretty comfortable temperature, but if that environmental conditions were to fail, the pressure suit that we were wearing was also able to keep us alive if the temperatures got really hot in the cockpit. The airplane is, every time I look at one of these where somebody calculates how long the airplane would grow, because when you heat metal up, things expand. Here's one that they've published 3 to 4 inches in length, 1 and 2 inches in width. Somebody who's like Steve here is a good engineer, could probably calculate those numbers, and each person might come up with a different one. Since this is on a Lockheed published document, I'm gonna go with these rather than what somebody else calculates. And here's where we talk about some of the parts of the airplane that were made out of that asbestos, not very much of it, but the fuselage chine, that little area in the front from the wing to the pitot tube and the very pointy end of the airplane, it comes out like a manta ray's shape, and that did several functions. When they first designed the airplane, it had a fairly circular fuselage, and it would go a little higher, but they said, no, when they were getting ready to accept it, we don't want an airplane necessarily, we'd rather it be stealthier rather than fly higher. So if you have to make a compromise to make it stealthier. And so the chine shape came out, and that was a very fortunate thing, because somewhere in the neighborhood of 35% of the lift of the airplane comes from the forebody or the chine area. And that really helps reduce the drag on the airplane by reducing trim drag, as well as giving you greater lift. And so you have here there it is even in print, 35% of the lift from the forward part of it. The airplanes, when it's cruising, most of us, you look at the airplane as it's sitting on the deck in there, it's sitting on its wheels, and we think that's how the airplane flies. In reality, it's more like a speedboat. It's tilted up like this at about 6 degrees. So when you go look at that aircraft, take a look at how the line of the airplane comes along, and then look at its pitot tube, and you'll see the pitot tube is down just a little bit. And if you look at where the spikes are, the spikes you would think would be perfectly in line with the nose of the airplane when you stand back from it. But in reality, they point down a little bit because the air is actually coming at it like this a little bit. And then if you really look careful at the spikes, you'll see that they're also canted in as well, because the bow wave coming off the front comes around and enters the engine more perpendicular, or exactly opposed to that position of the spikes. So the air is coming in from down and inboard a little bit at that time. Oh, yes. Oh, and the very last thing, they talk about the Elevon mixer, the flight controls. It only had one set of flight controls going across the back of the wing. They acted both as the elevator and the ailerons, so since they called it the Elevon. But the little mechanical mixer, it's about as big as a basketball, and it takes all of the push and pull rod inputs from the pilot's stick back to the back and transfers that into motion to be able to put this one up, this one down, left, right, both up and whatever. And it is a mechanical engineer's Swiss watch enjoyment to look at it and see how pretty it is. And it's also made out of some really neat material that we don't see very much anymore. And it sustains the heat back there. But if you ever have somebody reveal to you what that looks like, you swear you're looking inside of a Swiss watch. And we had what was called steam gauges, big round gauges. Today we might try to do something else, but this is what we had. It has a map projector, the gray square in the lower center. You could do a number of different things with the airplane that you can't do with others. For instance, the third, the second to last bullet where it says manually adjust the engine temperature. Normally that's done on the ground. A guy adjusts it, sets a little screw, runs a safety wire through it, safety wires that down, and the pilot doesn't get to adjust what the temperature of the airplane runs at. In this particular airplane, if things weren't running right, he could take it out of the auto mode and beep it up or beep it down a little bit so as to make the temperature go higher or lower. Even though he had the throttle full forward, he could adjust those. We tried not to mess with that too much because it was easier to make things go worse than it was to get better. And, oh, the very last one was a Malcolm laser generator, and it produced a line that went through the cockpit. When we started flying this airplane in daytime, that was really a pretty good thing, but it was nice to be able to see visually outside where the horizon was and how to adjust the airplane. As we started flying it more and more at night, we realized we really depended on seeing visually to make the little tiny pitch inputs and stuff. And someone came up with this laser generator that put a line through the cockpit at where the real horizon would be. Remember I told you we were flying pitched up a little bit, so the horizon line went through the cockpit, and as you moved the nose, that horizon line would stay level and it would move up and down. And it was really a marvelous thing for us flying at night to help be precise. Now, compare that to the F-35 that I show here. There's not a single round gauge in it. It's all on a touch screen, 8 by 20 inch wide touch screen, like laying two 8 by 10 laptops together. And you look out through a helmet that all of the information is displayed right on the inside of it. But I don't think it would sustain the heat that we have to deal with right now. There'd be some work to do before that would work. Back seat. So he has a view sight that allows him to look out the front and down. Radar display. He could take side-looking radar shots, see what the image was, but not instantaneously. It was about 30 seconds, if I remember right, delay before you actually saw what the radar picked up. Is that right, Don?
Yes.
Yep. And then there was a moving map display, which at the time was just fantastic. Today we think of Google Maps and Apple Maps and Waze and keep track of where we are. Remember, this was before GPS, so we couldn't do that. And so what they would do is figure out where we were flying, lay down real paper maps, cut out where we were going, well, put a line down where we were flying, take pictures of that, and then take the film from that and embed it into one long stream. And so this would start moving along, and as long as you were flying at the proper speed, the map just rolled toward you, sort of like a self-playing piano where you got a roll coming at you. And as long as you didn't deviate off, you knew exactly where you were. But if you deviated off, it wasn't exactly going to help you very much. So, yep, it was, the moving map display was better than anybody else had, but it had its problems. And the backseater also, the Astro Tracker. I told you we didn't have GPS at the time. So how do you navigate precisely? They wanted us to go right up against somebody's hostile border and to guarantee the president that we wouldn't cross their border and get in trouble, but we could go right up to the edge of it. This gave us a plus or minus about 300 feet. Well, when you're 15 to 17 miles in the sky and you can assess your lateral position within 300 feet, that's pretty good. But how did it work? In the back of the airplane, you can see where it says the tracker up there. We sometimes, after Star Wars came out, referred to that as R2-D2. It would look up and see stars during the daytime. And it would have a constellation, a map of what stars to look for. And it would start looking and finally say, oh, I see that one. That was A star. And then you say, oh, I see that one. That was B star. And then finally, when it got the third one, C star, it triangulated your position, and if the pilot had auto nav on at that time, the airplane would go boop into its little turn, move over a little bit, and then roll out. And I'd always say, we got the third star, right? And the backseater would tell me yes, because I didn't want the airplane just turning on its own when I didn't expect it. And now we're locked in. And so the Astro Tracker provided all the information for us flying around And what's useful about it is that we were flying above the clouds. They've tried to put this on other aircraft, and it's more limited, that have to fly under clouds, because if you can't see the stars, then you have a problem with an astro tracker. So it's an excellent aircraft to use that in. I think they put it in the 111, and it works some of the time, but not when there's 40% clouds above you.
Okay, I'm going to step in here because you're being really modest about a lot of this stuff, okay? And I want to toss in one thing that's really, really, really important here. So you're flying really close to a border. How close to a border?
Yeah,
Really close, right?
yeah.
And they're traveling a mile every second and a half. And with these, what are now considered to be rudimentary navigation systems. And if you violated a border, what could happen?
Well, they'd probably shoot at you.
It'd shoot at you a little bit, but it also became an international incident. And so I want you to think about the risk that they were taking. They talk about it very casually, but a mile every second and a half means that if you get off that line, you can deviate very quickly into a place you're not supposed to go.
And then the president gets upset, and then you get upset. Yeah.
I'd like to add to that.
Yeah, Robbie.
During our pre-mission briefs, we'd go through quite a few slides and stuff, but there were rings, and they will enter the ring, fly through the ring and out. Those rings were their Soviet missile rings. So every mission, they were in threat areas.
And if the bad guys at that time thought we were violating their territory, they had no compunctions about shoot first, ask questions later.
Something you may not understand is that the SR-71 turn radius was about 90 miles. So if the border is the edge of the stage here, 90 miles before I get there, I've got to start turning to not cross the border. So if I missed starting to turn 90 miles ago, by 2 seconds, I've gone 1 mile, and now I've crossed the border if I stay on the computer track.
And because they wanted us to stimulate the enemy's air defense systems most of the time, they didn't plan our routes like you'd plan your highway, where you have a major highway and you have an intersection coming in and you blend it in so that you see how nicely it is and you can move over to it. No, they wanted us to go 90 degrees to it, turn at the very last second, and then roll out and make sure that it, you don't want to cross that, but we want you to be 300 feet from it. Yeah. So, I trust in the astro-inertial. Okay, you might notice on your particular aircraft there's some bumps on it that you might not see in earlier pictures. I don't remember exactly when these started going in. It was in the 80s, but they were defined up here as being defensive systems. One would be a receiver for an enemy fighter who was trying to lock onto you from the front, and then the lower ones that are circled there are jammers that would jam his radar as he's going along. And we really didn't feel threatened by an enemy airplane. Even the MiG-25 and MiG-31, which were reported to be 2.8 to 3.0 aircraft, they were more 2.8. If they went 3.0, it meant that they took their engines and heated them up so much that they warped them. And so the engines were no longer any good. The guy would be lucky if he got it on the ground. And if he got it on the ground, it was a double engine change. And that was from just reaching Mach 3 for a moment or two. So them trying to catch us from behind, that was a no player, even though people would say, oh, you got to worry about that guy. In the nose, it might happen. The missiles get fired, and there's a maximum range you can fire a missile and a minimum range you can fire a missile. On the nose, with this airplane moving at 3,000 feet per second, the other airplane's probably going at least Mach 1, maybe Mach 2, and so you might end up with a 5,000 to 6,000 feet per second closure rate. The minimum and maximum launch time may be 1 second, and if things don't work right there, particularly in the fighter who's using vacuum tubes in order to be able to do this, it's not going to work very well.
Off the coast of California, we would work with the Navy, and they would know when we're coming, what our track was, and so it was a, you know, we were sitting duck, and they couldn't lock on many times.
This was for the Navy Top Gun. We provided them high-speed tracks for them to train their Top Gun students on. We did the same thing for the Air Force out over Nellis, and one time I asked the guy, I said, hey, as I enter in the airspace, can you give me a little bit of freedom instead of just flying exactly the same route and having my IFF on? So he said, oh, sure, I'm working with F-15s this time. He says, sure, no problem. So as we entered the airspace, I'm listening on their VHF frequency to them talking amongst themselves, and I hear one of them say, oh, okay, Judy, which means I've got the intercept, I'm taking over, ground control, you can be quiet. And I told Terry, my backseater, turn the IFF off, and I turned the airplane 12 degrees. That's all, just 12 degrees. After it, the guy called me up for the debrief, and he said, what did you do? My steering dot, which was right on the nose, went up and to the right, stuck there, and in my F-15, I couldn't turn it hard enough to bring the dot back in to steer at you. I said, we were going Mach 3 instead of the Mach 2.8 that you wanted us, and we turned our IFF off so you couldn't see us anymore, and then I turned 12 degrees. That's all. I didn't do evasive maneuvering. It was a 15 to 20 degree bank turn, put, over to 12 degrees, rolled out, and it destroyed his whole solution. Enough said. So our special airplane that we had two of at one time, and one of them crashed, is this trainer, and you can see that it has a separate rear seat that's elevated above the front one, and it allows an instructor pilot to sit in the back to train the pilot in the front. The rest of the time we trained in simulators. I think I had 200 hours of simulator time before I got to touch the airplane from a pilot flying it. You know, I got to sit in it a couple times drooling on it, but not to fly it until after I had about 200 hours. We wore basically the Gemini suits, and they eventually changed the color a couple of times on the overall outside of it, but essentially the suit didn't change much. It would keep you alive if we lost cabin pressurization long enough to descend or to continue the mission if you had to. And because a lot of times you were over places where you didn't want to go down right then. You wanted to stay up, so you didn't want to be subjected to descending to 25 or 35,000 feet. This is Buzz getting into a suit when he was, like a lot of the rest of us, a lot younger. We got into it by a zipper in the back, and you got help from... There's a lot of things about this airplane that I have to start giving out compliments right now. People like John and Mr. Butterfield here, Robbie, they prepped the airplane and made it ready to go. The physiological support people that pre-flighted my suits helped me get into it, helped me strap into the seat. I don't think I could get into this suit. I could get out of the suit with very good difficulty by myself, but I don't think I could get into it by myself at all. And please, it's not just the air crew. It's the entire group of people that made this airplane go. To the engineering staff back at the Skunk Works when we had a big problem and we go, uh-oh, what do we do now? So it's more than just, we're the ones that stand up in front of you, the pilots and the RSOs, and get a lot of the glory. But there's a lot of grunt work going on behind you that you don't know about, and it's almost a work of love because they certainly weren't paid enough to do what they did. And so the airplane climbed out, flew over hostile territory. There we would fly about 3.15 to 3.2. It consumed quite a bit of fuel during the takeoff and the climb. About a third of the fuel was used up just to get to the initial altitude, and then we started cruising at Mach 3 in burner the entire time. Remember, in the 50s and 60s, most other aircraft were limited to maybe 10 minutes in afterburner. One or two might be able to exploit it more than that. And we said, oh, we want to cruise in afterburner for the entire time. And so it's another one of those things that the engine had to be developed so far different than the engines they had in other aircraft.
Yeah, just real quick to calibrate when he said they burned a lot of gas, they were burning about 2 gallons a second. Okay.
Yeah, the fuel tanks are about, the fuel lines are about, to the afterburner, are about as big around as my arm. So this is the neat picture. But, so I've got, BC, you've got 900 hours, right, plus? More than your total time in the airplane?
1,217.3.
The high time pilot, yeah. And, .3, and I have 535.
Don't knock .3. .3 is 18 minutes.
Yeah, and I have 535, but I'm sure BC will say the same thing. The amount of time that I spent looking out the window, just sightseeing, is about 2 seconds at a time, and if I added up all the time that I looked out the window in my 500 hours, I estimate 15 minutes or 20 at the maximum spent just looking out for a little bit, and then heads down, pay attention to what's going on, buddy, because we used to laugh that as soon as you started looking away from it, that's when she would decide, okay, he's not paying attention to me, so I'm going to give him something to wake him up. So we carried cameras, a number of different cameras. So we had an optical bar camera if we were carrying a nose. The noses are replaceable, and you are fortunate enough to have a replaceable nose sitting by the airplane, so you can see how it goes on and off. But the nose comes off, and inside of that nose there could be an optical bar camera, or they could be a radar mounted. You couldn't have both of those together. But also along the sides of the airplane in the chines, you had other cameras that were always there that you could have, so that even when you're carrying a radar nose, you could have the optical cameras there in the chines called tech cameras. And it surveyed plus or minus 100 miles from the center line of your aircraft out, so you'd look at things away from it as well as to what was directly below you. And it really was, from a radar and optics, a real collector of information. Then the airplane also had space in it to collect electrical information. So when people were talking on the radio, transmitting their radars and stuff, we would collect that information. And what's really neat, although the U-2 hangs around, collects some of the same information, but he's at one point in space. So when he says, oh, I see a radar, and that radar is something that's pretty important, but it's 090 degrees from me, and you get a single line of bearing. Well, in the SR-71's case, you see that radar, and you see it 20 seconds later, you see it again. Now you've gone so far that you can triangulate its exact position instead of just saying, oh, it was 090 from here to the horizon somewhere. In the SR, you could say, oh, it's 78 miles right there, and you could locate it precisely right away. And here's a beautiful picture of them transferring fuel, and you can see how the airplane, even though it's very slow there, so it's pitched up probably 9 degrees, but when it's cruising at altitude, it has that same sort of nose up in the air attitude while it's cruising. Here's where
one thing real quick, okay? When they were refueling and they said they were up at about 9 degrees, if you got above about 10, 11 degrees, the airplane would start to pitch up and go out of control. And so they were flying just, it was a little bit of work.
Some people say we were flying as slow as we could go, and the tanker was going as fast as it could run its little feet. But it may not have been that extreme. And I found after doing it for a while, it became just another job that you learned how to do, and you did it well. But the first couple of times refueling, you're moving back and forward, particularly when it came time to where, okay, I've run out of all the power in the engine without the afterburner, and I'm starting to fall back now. Now I have to grab one burner, put it into afterburner, and then real quickly grab the other throttle, and as soon as the burner lit, it took maybe 2 to 4 seconds for the burner to light, then pull that one back to balance how much I need it. And so there's a little bit of excitement there for a moment or two until you stabilize out.
Yeah, and remember, the burner's on one side, right?
Yeah, about 15 feet wide, so it wants to turn you sideways too. Yeah, you know, it's little issues that you learn to deal with, but it's a nice training. Here's all the places. The one on the far left is Beale, where we all basically lived. And then RAF Mildenhall in the center, that's the one where Robbie was the maintenance chief for it. And then Kadena Air Force Base way out on the other side. We would fly from Beale, not necessarily in the SR. A lot of times we would reposition in a tanker. Occasionally we'd get the luxury ride by going out in the SR to go to one of these locations, and then we would fly from there. There were usually, Robbie, you had 2 airplanes stationed most of the time, right? And I think for a while they had more than 2, but when I was flying, there were 2 at Kadena all the time. And every once in a while, they would take them back to Beale or Palmdale and send out a new one. But all the little red circles are the primary areas of interest, some of which you can see now are still areas of interest. And then here's the last flight. I know I told you I'd be quick, and I have not been. Here's the SR fleet as it was retired. These are all the airplanes that we had that were flying at the time. And if I remember right, the one at the very back, 90 degrees to us, is the C model, which was kind of a weird airplane. When they lost the one of the 2 of the trainers, and they had a front seat from Steve, what was they had used it for something. They had a front cockpit to do something. I can't remember what it was. And they stuck it to the back end of an A-12. Yeah. And so, BC, you flew that one, didn't you? No. Did you? No? There was somebody last night in the podium that said, oh, it was Al George said he flew it. He said it was really neat because it was a little quicker. He could feel that it was lighter, and the acceleration was a little faster. But that's the SR-71 C model, which was a conglomeration of 2 different types of airplanes welded together. Okay, so that's my time, and I spent too much of it. I'm open for questions from anybody in the audience. Yes, sir. And we have a microphone, and if you would please, we'll see if we can get one of the right people to the panel members. I'm not going to talk anymore. Yes.
So what were some Soviet SAM systems that worried you, except for the interceptors?
Don, you were probably closest to that.
The primary SAM at that time was the SA-2. The SA-2 had it would get to our altitude, and the missile itself would go about Mach 3.5. It had an 18-mile radius, but it was not just a circle around the SAM site. It was a cone that started from the SAM and went out. It couldn't, if you were in real low, and I flew the F-4 in Vietnam and was shot at in one mission by 9 SAMs. And if you were in real close, it couldn't get to you. But as you went away and altitude increased, so at about 5,000 feet, the diameter of the circle is about 8 miles. And at 12,000 feet, the diameter of the circle is about 12 miles. And it gets to eventually, it's 18 miles at about 50,000 feet, and then the cone inverts as it goes up higher. And at our altitude, usually we were 75 to 80,000 feet, depending on what the fuel load on the airplane was. The circle at the top, the cone that it could operate in, was about 1 mile in diameter. Well, our defense against that is a light in the cockpit would say they've launched at you. We had a launch light, and we would simply push the speed up. So we got through the cone at the top before the missile could get there, and they were always going behind us.
I was about a decade later in the airplane, and we were also concerned about the SA-5s that were around different places. Now, it had close to a 200-mile circle around it, but as far as I know, they never fired any one of those, but they would light us up occasionally with the idea that they were trying to shoot it at us, or at least figure out what we would do if they did shoot it at us.
And one thing to remember, one of the other advantages the Blackbird had in being so high, the air is so thin that the missile's ability to what we call in-game or do that final correction to get in close enough to be within a lethal radius, it was very difficult to maneuver. And some of the missiles have pretty big fins on them trying to compensate for that, but that further complicated the solution for the Soviets.
I guess I have 3 questions. One was, how far away from the stall speed were you when you were refueling? Another one was, what was the maximum altitude, if you can tell us that currently? And the third one, I don't know, I forgot what that one was already. But
BC is our test pilot, would you please?
Well, the stall speed of the SR-71 varied a lot from the gross weight. The empty weight of the SR-71 is 60,000 pounds. We carried 80,000 pounds. So you put those two together, when we were refueling, we went up to 140,000 pounds. We'd start off with maybe 15,000 pounds, 20,000 in the airplane. So at that time, it was relatively light, and our stall speed was, probably around 140 or so. But we never got close to that. I mean, you did not stall the SR-71. SR-71 had a chine in the front and a delta wing in back, and if you got into a stall angle of attack, the back stalls before the front does. And so what you would have is the back stalls, front still flying, and you get that action. SR-71 empty and symmetrical G, maximum G was 3 Gs. So it could not take any kind of recovery that required more than 3 Gs. There's one dramatic picture of the SR-71 on YouTube when it was carrying one of these drones, and it came back and hit it, and you could see in the video very quickly the airplane pitched up and quickly disintegrated. At high speed, 310 knots was our minimum speed above 25,000 feet. And refueling, the optimum refueling altitude was 26,000. If you go any higher and to maintain the tanker is Mach limited as well as dynamic pressure limited. So if you go higher, your dynamic pressure is going to be less for the same Mach. So you're going to be closer to the stall speed. So that's why they put 310 knots as the minimum speed above an altitude. So we would be pretty maneuverable getting up to the tanker, but then when we got a fully fueled airplane, now you're talking about an airplane that's really, it's heavy, it's not as maneuverable, you can't pull as many Gs, and you just have to treat it very, very gently. So,
Max altitude.
Max altitude, my highest I think I went was 86,000. The flight manual recommended 83 as the maximum. I know one pilot that went to 90, foolishly. But I say 90 is the highest I've ever
Don
heard.
Helt's got the record, and I think it's 85, and I don't remember how many feet,
Could be.
hundreds of feet.
I think the official altitude was 83 or something, but I'm not sure. Anyway, nobody knows, because you don't. When you're flying this airplane, I never intentionally broke a limit.
Yeah.
And so if you wanted to zoom the airplane up to 95,000, you may or may not get away with it. But you'd be, I mean, what a stupid thing to do. So yeah. We just flew the airplane. All of our missions were very closely planned and choreographed. And
we followed
for
the
one,
script.
and none of us ever got out of that, because this airplane had so much it was a secret airplane, but in the official world, it had so much visibility. We overflew Cuba, we overflew the Middle East, we overflew Central America. We did not fly over the Russia, or I'm sorry, the Soviet Union, or communist China, but we flew within 12.5 miles of their coastline. So anyway, we just had to be very cognizant to stay on our profile.
Any other questions? Yes, sir, another one?
Over to you. Thank you for your service. Couple of questions. How long was your longest flight? How much time between flights? And how long between did you have to change the engines on this thing?
Okay, so the longest, BC, I didn't have a terribly long one.
My longest flight was 10.5 hours,
Okay.
and that was from California to the Soviet Union and back. And then the longest flight, I believe, was 12.5 hours, and that was during the Middle East crisis, 1967.
Yep.
And I think that was 12.5 or 13 hours.
And the reason why that one went so long is because we wanted to fly the missions out of England, but at that time, England was concerned, the government in England was concerned because they were getting all their oil from the Middle East, and if they allowed us to fly from there, they might cut it off. So the mission that went 12.5 hours was flown from the east coast of the United States over the Middle East, then back through the Straits of Gibraltar across the Atlantic, back to the east coast of the United States. That's a pretty long distance. And then we had engine change.
Engine changes were, there was time on the engines, so they would change them, but they weren't frequently. But I can add this to the flying. 1986, Colonel Gaddafi at Libya was giving us a hard time, and he is training people as terrorists. So Ronald Reagan, our president, said, we're going to bomb Libya. And they did, and we bombed them. We did the BDA, Battle Damage Assessment. We flew 2 SRs out of Mildenhall, down through the strait, and around and back. And each airplane flew 3 missions in 3 days. So we had 2 airplanes, had 6 airplanes, and we kept on turning them. And it was quite difficult because you have a 25-hour inspection every 25 hours. So we had to come up with Det 6 and engineering to how are we going to do these. And the airplanes were hot. They were ready to go every single time. So we did quite a bit of work. And I understand they did something like that in Okinawa as well. But it was pretty astonishing from our viewpoint. And we had to prepare for that and have 2 OBC noses on board and have all the equipment work. And remember, in England, I only had 2 airplanes, so I didn't have a spare.
Yes, sir.
I had a question about the camera systems. So this is the tallest, fastest camera that was ever made back then. And anyone that's taken a photo out of their car window knows that it's always blurry, right? So going 30 or 35 times faster than a car goes might, it must be very challenging to get a clear photo. And so I would just like to kind of better understand how you're able to tilt the camera and to better understand like the radians that you were traveling over the Earth to get that clearer picture. Otherwise it'd be blurry, I'm sure.
Don?
The OBC camera, which was one in the front nose, prior to a mission, we would preheat the lens so that the thermal shock that would go through the lens otherwise would not occur. We get a nice, clear picture. At speed, we would feed this information to the camera. It was tilt as it ran every frame down, so it kept the picture in focus, and we were tracking what we were looking at. And I'm sorry, did you have another? That the height was already built into the focal point of the film, so we were going to get it in focus. We had to be over 30,000 feet before it would focus. But at 80,000 feet, that wasn't an issue. And the aircraft fed the speed data to the OBC, so it would tilt as it ran a frame, and then it would come back up and then tilt down again. So it kept track of the target that it was looking at. The tech cameras just took a picture, a single shot, rather than run a continuous roll. So they would point at their target, take their picture, get the new data from the ANS, point at another target, take another picture.
No.
The ANS supply would notify the tech. They had geo points where we wanted to take a certain picture, and it would send that data down to the tech, and it would point it and command it to take that picture. The backseater had the option to manually intervene if he felt the mission wasn't being accomplished the way it should be, and he could direct the cameras to take pictures.
Steve, take the microprocessor
Yeah, there were
apart.
no microprocessors on board. I mean, we're talking about largely analog systems at that time. There was some digital work on board, but this was solid-state electronics, not microprocessors.
The tech cameras did have a mirror that would, if you're trying to take a picture of something moving, you're moving the camera across for a kid catching a football or something. But as you're going by, we're going so fast that the camera had a mirror that would pan, if that's the spot, it would, as we go along this way, it would focus and keep that spot in focus during the time of the frame. And that little mirror is going up and down like this as we go along the ground.
Sort of a two-part question. You mentioned spending about 200 hours in a simulator to get prepared for your first time flying, and then kind of how difficult getting the refilling like angles were, or some of the other maneuvers. I was curious, in terms of your preparation to fly, what were some of the hardest like maneuvers or tasks to learn before you were allowed to just go?
BC, you want to take that one, sir?
I didn't understand the question.
Okay. He was talking about the 200 hours worth of simulation time, and what was some of the things that we prepared, what were the difficult things that we prepared to do for flight?
Oh my gosh.
Did I summarize that correctly?
Well, the hardest thing to learn, for me anyway, was the operation of the inlets. The inlets are very complicated. We had forward and aft bypass, we had a spike and door, and we had to have all of that in concert. The spike, the pointy things out of the engine were translated aft 26 inches from subsonic to Mach 3.2. And if you were a half inch off of the specified position, you would degrade the mission, possibly to the point of not being able to complete the mission. So that spike had to be within a half an inch. It was done automatically normally, but there were a lot of instances where you had to take over a manual operation of that. And manual operation plus flying the airplane just really increased the workload 50% or so. The other things we had to worry about were, of course, center of gravity was really big. The center of gravity was found by a test pilot during the initial operating phases when he was in a turn and the airplane went out of control. So they were thinking about gravity aft because you get better gas mileage. So we flew right at the aft CG limit was where we flew all of our missions. It was at 25% mean aerodynamic chord. If you got 25.2, you're really in a very, very dangerous position. So that required a lot of attention. How you burned your fuel. We had 6 tanks. They were all selectable. They all came on. We had to learn the tank sequencing was automatic. I can tell you the automatic sequence: 136, 135, 35, 24, 24, 24, and 4. And that if it didn't go in that sequence, then you knew something was going to happen. So we had to worry about this, the CG control. We had 2 switches, one for forward. One for transfer of fuel. Oh, one for transfer of fuel, and the forward, and one for transfer of fuel aft. These are all the things that we had to worry about that most airplane pilots don't have to worry about. So, and plus the fact that you're going 2,200 miles an hour.
And one of the comments I'll make, since BC was my instructor, the forward one, you couldn't, let's say you couldn't, you seldom would get in trouble by transferring fuel forward. Transferring fuel aft, you could get in trouble. So the engineers wisely made that a switch that you had to hold aft, because like dump switches, when I was flying the F4, whenever I'd go, okay, I got to dump a little fuel, I would dump fuel, and I learned very quickly, never let go of that switch because your mind will find something, oh, squirrel. And the next thing you know, you've dumped too much fuel. So in both transferring aft and dumping fuel, you keep your hand on it, and then when you're, okay, now I'm turning it off. Now I can go look at that squirrel.
But let me add one thing. The airplane was changing weight to the rate of, I think it was 11 pounds a second, I think. So the weight was changing dramatically. So as you would burn the fuel down, CG was shifting. That's why you see the tanks, moving between tank feeds. But that was something you had to monitor, because if it wasn't quite going right, it was up to these guys to make sure the airplane didn't go out of control.
Keeping the pointy end going forward was very important.
So I'll just comment. Apparently that squirrel was a flying squirrel. Okay.
On the CG, I had a calculator. It was a manual circular slide rule, and I would calculate the CG about every 5 to 8 minutes to make sure it was where it's supposed to be. When you're supersonic, it's between 22 and 25% MAC, so the CG is aft, so that the position of the airplane is optimum through the air. You're getting the best gas mileage. But subsonic, it had to be forward of 22. If you're aft of 22 of subsonic, you can pitch the airplane up. So, and every time we came to a tanker, you had to have it forward. And so the CG's changing all the time, and it's very, very critical. And it was a constant calculation.
Very good question, yeah.
Brian Schul, in his book, The Sled Driver, talks about a popular story. I'm sure you must have heard of it. It's called LA Speed Check. And LA Speed Check. Yeah. I wanted to know, have you ever had such an interaction with other aircraft that are not concerned with your mission? And my second question would be, what did you think, if ever, about ejecting at Mach 3?
Well, that's a lot of questions. LA Speed Check, the LA Speed Check story is a guy in a Cessna says, LA Center, what's my ground speed? And he says 110. And then a guy in a Baron, what's my ground speed? And it's 250. And then an F-18 pilot says, what's my ground speed? And it's 560. And then the SR guy says, well, LA Center, what's my ground speed? He said 2,000 miles an hour. Well, I really think that's a bogus story, because the Cessna talks on VHF, and we're talking on UHF, the center. And so I don't think it's a good story, and it's good on the internet, but I don't believe it's really true.
It is a fun story, though.
Got a question right here.
I'm hearing you folks talk about things happening in seconds.
Mike, a little closer to your mouth, please, sir.
Okay. I hear you folks talking about things happening in seconds and being off by miles and things like that. Ask all of you one at a time, please. What's the worst mistake you ever made?
Well, I can tell a worst mistake that I ever made, but it wasn't in an SR. I was flying in a U-2 in a pressure suit, and I was fairly new, and my microphone wasn't working. And the mistake that I learned from was to really learn your equipment and learn everything about them possibly. So I went, I remember in training, I'm only a new guy. I've probably got 10 or 15 hours in the airplane, and my mic is not working, and this is important because I'm flying in the States and they want to know where I'm at and stuff. So I look over and I see these cords coming up into the pressure suit, and I go, yeah, this is the one, and I pulled it apart, and it was my oxygen cord. And I realized that, and I went, oh, you dumb. And then I struggled over here because moving around in the pressure suit is awful. And I got one of them, there were two of them, I got one of them back together again, put the clip back on it and said, all right, now pay attention what you're doing now and be very, very cautious. And from then on, but gosh, that would have been really terrible I mean, everything in oxygen comes through those hoses into your helmet. So I never repeated that one, and I was very, very double sure every time I ever disconnected anything else after that. And that's kind of embarrassing to talk about, because that really meant I was the real dummy in the block. BC, can you beat that one?
Oh, gosh. We don't like to talk about our mistakes, but I will tell you my worst mistake I made in the SR-71. In addition to controlling the inlets and all these things, we also controlled the inlet guide vanes on the engine. The inlet guide vanes had two positions, cambered and axial. Axial was for subsonic, and then the cambered was, we got to about 1.6 Mach or so. And this was an overflight of Cuba, so it was a very important mission, and it had a lot of people looking at it. So I certainly didn't want to abort this thing, but we flew what we call hot leg, a Mach 3 flight to go to the tanker to refuel and then to overfly Cuba. I put the IGVs in the proper position, which is cambered position for high speed. And then coming down, there's a checklist item to put them back into axial. Well, I didn't do that. Just missed that item on the checklist. So I went down and I refueled in axial, which it seemed like a little sluggish. It would back up and say that in axial, you don't get as much thrust out of the engine as you do in cambered. So the refueling went okay, and then I started up and started climbing, and noticed that the fuel was going down a little bit. So we're looking for fuel leaks and things like that. Well, I realized at the time when it came in the checklist to go to the cambered position, I was already in the cambered position. So I made the acceleration from Mach 0.9 essentially to 1.6 Mach with the inlet guide vanes in the wrong position, which cost me about 4,000 or 5,000 pounds of gas. Well, my bingo was about 3,000 pounds. Whatever my bingo was, I don't remember what it was. The bingo is the fuel that you need to refuel from the tanker, and if you don't have the bingo, then you're supposed to go to your alternate. But my alternate was, I think it was, well, I forgot.
Key West to New Orleans, usually.
Yes, that was right. It was New Orleans. So on the way down, I am below bingo, and we had two tankers waiting for me, and I say, well, now the below bingo meant that we could land and still have enough fuel to go around once. So I'm thinking, I have enough fuel to go to New Orleans if I go directly, but if I refuel, I may not. So what did I do? To save face and everything and to complete the mission, I refueled. Luckily, everything worked out okay. But that's the worst, I guess that's probably the worst thing I ever did in any airplane, but it was just the realization, and it was part of this thing about the SR-71 being more complicated than any other airplane. You just forget one little switch or something like that, and it could be bad.
So, but a really good question is, what did the airplane do to them?
John?
The worst mistake, I guess, was the DEF-H, which was a high-powered jammer for the missiles, for the SA-5. On a test flight out of Okinawa, the tech rep said, hey, run my system, make sure it's running okay. Well, like the switch that you turn on and turn off, I was just supposed to run it for a few seconds. And I turned it on and then got diverted to something else, and I came back about 5 minutes later and turned it off. Well, when we got back, something had melted in the DEF-H because it put out so much power. My other mistake was we were at Goose Bay, Labrador, and had diverted in there for overheat in the cockpit. And on the way out, after 48 hours at Goose Bay, there's no limited tech support, so I had to align the inertial system, and I got it all aligned and we're ready to go. And we go out and it doesn't get a star. Well, if it doesn't get a star, then your navigation is just inertial navigation, and it's going to have errors in it. And as we're proceeding across the tundra of Canada going back to California, no lock on. I could see Hudson Bay in the radar, and I said, well, okay, I know about where I am, but I don't know exactly. And I had put the time in the inertial off by 1 hour. I didn't put in the right GMT. We got home.
Yes, sir?
Okay, back to the cameras, maybe it's the U2, but I was thinking some of the cameras used a mechanism where the shutter was a narrow slot and that the film moved in sort of a synchronization with the ground speed so that the camera ran continuously and then the lens focused through that slot. Was that on the SR-71 or maybe the U2?
An optical bar camera works that way?
Because that would eliminate the problem with the
I think there was
motion
an EO camera that did that, but that was after I had departed the program. And I think there was one carried on the U2 or on a drone that did that. I saw some image of something like that at one time, but I don't know of that being on the SR.
The question over here.
Yeah.
First of all, thank you for your presentation today, because I know that even though the plane itself hasn't flown in over 30 years, there's still probably a lot of stuff about it that none of y'all can tell us. But I guess my question is this. How do you go from being a part of the SR-71, which is, in my opinion, the greatest plane ever built, to, I guess, the rest of your Air Force career?
You mean just becoming ordinary people
Yeah.
again instead of people in it?
Pretty much.
It's you have to remain humble. You have to realize that it's not you that made that airplane go. The airplane made you go. You know, you just happen to be the fortunate person that got to be associated with the airplane. Amen. And it's easy to get the big head, you know, and think you're the God's gift to aviation, and you were just a lucky guy that got picked to, okay, we'll let you fly this, and you just go down on your knees and say thank you, Lord, because you were lucky. BC?
I think I can address that a little bit differently.
Yeah.
As you notice, I'm a little shorter. I'm 6 foot unfolded. When I was in the hospital, and it doesn't matter how it happened, but that's another story. I was laying there and I can't move. I'm a C4 quadriplegic. The nurse gave me a button, a simple button that I could press. And I couldn't touch it. I couldn't move my finger to touch it. And I thought to myself, I helped. I was part of a group that made this aircraft fly. That's an impossible task. But I can do this. I can move my finger. And I know I'm accomplishing something. If I can make titanium fly at Mach 3, I can press this button. So after I finished, I got the button pressed, I finally started moving. I returned back to school, got my degree because of this program. One of the engineers from Lockheed told me, get your degree, come work for me. So I got my degree, and then I worked for the Navy for 12 years as a SME, a subject matter expert on the Tarmac cruise missile. And they'd ask me about the airplane, and I wouldn't talk much about it because it wasn't my past, but it gave me a good foundation, gave me a good work ethic, and gave me an idea I cannot. Not is in not in my vocabulary. Does that answer it?
We have one over here, and then we'll come over there.
Okay.
Firstly, thank you for everything. Secondly, is there a way to actually see that Swiss watch gearbox that you described?
It's up to the museum and how they do that. A couple of the other museums have replaced that panel with a little plexiglass panel, but they allow you to walk under the airplane. The rules here would have to be modified before they could do that. Could we?
I've got a photo of it on my phone if you want to see it.
Oh, we have a photo, yes.
There you go.
Is there any sort of way to see it at all would be a slightly better question.
If you can make it all the way out to Blackbird Air Park in California, they took it out of the airplane. It's actually sitting below the aircraft itself. So you can see it out in the open and walk around it and get a good look at it.
In Kalamazoo, where they have the trainer, they've put a plexiglass panel in place of the titanium panel under it, and they allow you to look at it there. That's not that far in the grand scheme of things of a day's drive to go visit something, if you're a real airplane buff. The young man down here had a question?
Sure, thank you. There's so much that goes into this whole program with the motivation, the people, the technology, the training, and the perseverance through a program like that. To my knowledge, the Soviets never really attempted to duplicate what we did. What are some of the thoughts you have as to why only the United States went this far to do all these things, to make such a fantastic aircraft, and the people to execute that mission?
Freedom and free enterprise, American spirit. I think that's it.
And I'll add diversity of thought inside of it, because the Soviet system was extremely regulated, and there was a formula that was applied to the different bureaus. You will design an airplane this way. If you look between the Su-27 and the MiG-29, you see exactly the same formula. There was a lot of regulations that constrained this. They still had a lot of creativity and a lot of ingenuity, but working inside the Skunk Works, I'm not going to speak for the operational end, but on the engineering end, one of the things that Kelly demanded was people speak up and speak your mind, and you get all of the fleas and ticks out on the table and deal with them in real time. And that's not how a lot of other systems work.
Yes, sir.
American ingenuity probably is the thing. The Chinese are very good at copying stuff. The Russians try to steal stuff. But the ingenuity in America, because of our challenging thought, will say, hey, there must be a better way to do this. And Kelly Johnson was the absolute genius that came up with some of these ideas, and he put the team together that would challenge what went on, and they made it happen. And I understand that Kelly had a standard bet he would pay anybody $50 or $500 if they could take a pound off the airplane.
It was a quarter.
Just a quarter.
A quarter, okay.
But to win one of Kelly's quarters was something. He didn't often lose a quarter. Yes, sir.
Yeah, I had a question on the fuel leaking on the Tarmac. I had heard that it would kind of seal once you got up to cruise. I wanted to inquire about that.
There was a tech order on the airplane leaked fuel. The metal panels were held by a sealant, much as a caulk around a window. It was a high temperature caulk, and about every 100 hours the airplane would go into to be resealed, and they would cut the old stuff out and put it on. There was a tech order limit. They filled the airplane up, and it could leak 2,500 pounds an hour leak and still be inside tolerance. And I think this guy right here was flying an airplane that was leaking a little bit more than that. And the theory that it sealed up at altitude, I don't believe is true. I think it leaked.
The airplane was not designed to leak on the ground and seal up at altitude. That's a wives' tale. It's a myth. It was designed to be dry, and when it came out of the factory for the first several flights, it was dry. But this sealant that you use between between what we call a wet tank or wet cell, so the fuel is sitting onto the bottom of the the skin that you see underneath the airplane is the bottom of the fuel tank, and there are panels all over the place. And after a while, as you heat and cool, everything that they could think of got brittle and broke a little bit and would leak fuel eventually.
Yeah, and there's the other problem of sticking to titanium, which is a really strange metal. In the I think it was about 1985, the materials engineer at Lockheed, his name was Ray Burton, and his team came up with a sealant that would handle all of that expansion and contraction while being saturated with fuel and stick to titanium. And there was a proposal made to the Air Force by Lockheed to go through and reseal all the aircraft. And the Air Force looked at the cost to do that versus how fuel leaked out of it and said, you know, we'll just stick with the fuel leaking out of it.
Now, one thing that we don't mention much is when we park the aircraft, the first thing, like a runway closure or things like that, we have to say, where's your groundwater? Normally you don't do that because we don't want to contaminate the water. So we have to position it. I was in Germany and I had to refuel, and the guy in charge of the environmental, the whole country was there. This guy was way up in the government. He goes, he says, hey, you can't fuel your aircraft. And I looked at him and I said, hey, any fuel that hits the ground is just going back in the ground. Don't worry about it. And I had him translate it to him, and his jaw hit the deck because he couldn't believe I'm talking to him that way. I said, I got to get home. So we're going fuel and we're going to go. So they found a place we could refuel. So as a maintenance guy, we always had to look at other positions to make sure we didn't ruin the environment.
So we got one more question, and then we have a little short video to play to end this. So you have a question back there? Okay, up in front, yes.
Just curious, I'm reasonably sure none of you flew the A-12.
You're correct.
But were there any pilots that flew both the A-12 and SR?
Oh, yes. Yes, several of the early test pilots, you know, as the A-12s were coming out, they were testing them. And then when the YF-12 came out, they were testing it. And then, yes, so Bill Parks probably flew every variant of our airplane we've ever had.
Yeah, Bob Gilliland also flew every version, the A-12, YF-12, SR-71, and MD.
They were not very far apart in the design phase, time-wise.
Ken Collins flew them both.
Yeah, that's right.
And did any of you have the opportunity to fly either the YF-12 or the M21?